Okay, so today I'm going to derive Weyl equations. Okay, so first of all, the motivation for deriving Weyl equation comes from the fact that when we actually develop the Lagrangian of electroweak theory, we know that in electroweak theory, the W and the Z boson, they can distinguish between the left-handed and the right-handed particles, or let's say they can distinguish between the chirality of the particles. So yeah, it's motivated from that point of view. So actually let's start with the development of Weyl equation. We will start from Dirac equation. Iota gamma mu d mu minus m into psi is equal to 0. So this is our Dirac equation. And now we are going to break this Dirac equation like this: gamma 0 d0 minus iota gamma I di minus m into psi is equal to 0. Okay, now we are going to multiply this equation with gamma 0. So multiplying this equation with gamma 0 and exploiting this gamma 0, gamma 5, gamma I. I guess, yeah. Okay, so we use these techniques, and in fact, let me tell you that the square of gamma 0 is unity. So here I'm going to multiply with gamma 0 and exploiting this fact. Iota gamma 0 d mu minus iota, and first of all I write gamma 0, which I'm multiplying, and then I write instead of gamma I, I'm going to write gamma 0, gamma 5 and sigma I, which are Pauli matrices, minus gamma 0 into m. I think is multiplying by psi. Okay, after that I use this identity, and I will be left with iota d0 minus iota gamma 5 sigma I minus gamma 0 m into psi. And yeah, here I forget to put in the d's of I, and I'm going to put them right now, di and di. Okay, so let's call this equation 1, and or we can also call this equation 2 and call this equation 1. Okay, now I'm going to multiply equation 1, that is this equation. I'm going to multiply so I'm going to multiply this equation 1 by gamma 5 and gamma 0, and we need to know that gamma 5, gamma 0 are not commutative, so their relation is given like that. If you change their positions, you will get a minus sign. Okay, anyway, iota gamma 0 and gamma 5, gamma 0, which I have multiplied, minus iota gamma I. First I multiply gamma 5 gamma 0, then gamma I and di comes in, minus gamma 5 gamma 0 into m, everything multiplying by psi, equal to 0. And again here I will get gamma 0 and gamma 0, so this will become 1 unity. So iota gamma 5 d0 minus iota, and this thing right here better with the red color, this thing right here is an identity which I explained earlier. So I can no. So yeah, I'm going to use that. Okay, I need to remove this. Okay, gamma 5 gamma 0, and for this I'm going to use this identity again, gamma 0 gamma 5 sigma I di minus gamma 5 gamma 0 into m is equal to 0. Okay, moving on. Iota gamma 5 d0 minus, this will give me identity, and here I have 2 gamma 5s and a sigma I, and gamma 5 square is also unity 1, so I will get here sigma I di minus, okay, if I change the order of gamma 5 and gamma 0, so I will get gamma 0 gamma 5, and I will get a minus sign, which will make this minus sign eventually a plus sign, into psi is equal to 0. Let's call this equation number 3. Now I'm going to add equation 2 and 3, and then divide it by 2. So iota d0 plus iota gamma 5 d0 minus iota gamma 5 sigma I di minus iota sigma I di minus gamma 0 m plus gamma 0 gamma 5 into m, and everything is multiplied by psi. Okay, and also dividing by 2, so yeah, everything is divided by 2. Okay, I've gone too far. So I take this term, these two terms common, and I will get 1 plus gamma 5 divided by 2. I take iota, I take minus iota sigma I and di common, and I will left with 1 plus gamma 5 upon 2 minus gamma 0, and I take common, and here from here I will get 1, and here I will get sigma 5 upon 2, and everything is multiplied by psi. Okay, here I introduce chiral operator, which is 1 plus gamma 5 upon 2. It is the right chiral operator, and the property of right chiral operator is that when you apply right chiral operator on psi, it will give us the right handed particles of the psi. And similarly, if I have here 1 minus gamma 5 upon 2, this is called left-handed chiral operator, and if you apply left-handed chiral operator on psi, you will get the left-handed part of the psi, which is psi L. Okay, now I'm going to write iota d0. This will give me, if I apply this chiral operator on psi, I will get right-handed part of the psi minus iota sigma I di di, and then when apply this on psi, I will get the right-handed part. And if I take this minus gamma 0 m to the other side of the equation, it will become gamma 0 m, and this is the left hand chiral operator, and it will give me the left-handed part of the psi. Okay, so I can simplify it more. Sigma I di into psi of r is equal to gamma 0 m psi of L. Okay, let's call this equation 4. Now I'm going to subtract equation. I'm going to do the same thing, but this time I will do the subtraction, and I'm going to subtract equation 3 from equation 2 and then I will divide it by 2. So subtracting equation 3 from 2 and then after divide by 2. So for my convenience, I'm going to copy these equations. I will paste them here for a moment, and then I will remove them later. 2, and here is 3. Okay, so for my convenience, I copied them here for the moment. So I'm going to subtract 3 from 2. So first I write the equation number 2, iota d0 minus iota gamma 5 d0 minus iota gamma 5 sigma I di minus, and this will become plus, iota sigma I di minus gamma 0 m minus gamma 0 gamma 5 into m, and everything is multiplying by psi. Okay, now I can remove these two equations from here. Their work is done. Okay, now I'm going to take common these iota and d0, and I will get 1 minus gamma 5. Oh yeah, I forget to divide everything by 2, so I'm doing it here. So yeah, whole equation is divided by 2. So this 2 will come here, if I take minus outside, iota sigma I di, I take these terms common, so I will get okay, so I will get, if I take the plus common, plus iota, so I will get 1 minus gamma 5 upon 2. No, I can still get 1 minus gamma 5 even if I take minus common. So yeah, my minus gamma will go to the other side and eventually I will get 1 minus gamma 5 and that will be my left chiral operator. Anyway, I take minus gamma 0 and common and I will get 1 plus gamma 5 upon 2. And everything is multiplied by psi is equal to 0. So I will do the same thing. This is my left chiral operator. This will give me the left-handed part of the psi. Similarly, this will also give me the psi L, and if I take this to the other side and this is the right chiral operator, this will give me psi R. So let's call, no, not yet, iota d0 minus iota sigma I di psi L is equal to gamma 0 m psi of R. It's equation 5. Let's write equation 4 and 5 together. So I d0 minus I di okay, sigma I di psi R is equal to gamma 0 and psi L. And equation number 5, this is 4. And let me write it, okay, I will write with a different color in the next point because that will be the conclusion. Sigma 0 and psi R. Okay, now if we take fermionic mass to be 0, for m is equal to 0, we will get Weyl equations. So this is our conclusion. I d0 minus I sigma I di multiplied by psi L is equal to 0 for m is equal to 0, and similarly I d0 minus I sigma I di, okay, psi right, and this is psi L is equal to 0. So these are the Weyl equations separately for the right-handed and the left-handed particles. Okay, see you next time. And the music that is playing behind is actually interstellar music, and the specific name of this video is interstellar definitive cut. You will like it when you are doing some mathematics and this music is playing. Actually it helps me. I don't know about you. Okay, bye bye.